Yes. Okay, तो ध्यान रखो बेटा. Okay. So the flux through this surface will be how much? That will be equal to Q divided by 24 epsilon naught. Isn't it? Okay. So this question. This question has been asked in a differ. Okay. So easily you can do it. Okay. So इसमें कोई rocket science है नहीं. Okay. So there is number one more is there. That's fourth case. Okay. Fourth possibility is there. There are four different possibilities. Possibility number first is that you can place the charged particle inside the cube. Possibility number second that you can place the charged particle on the face. Number third is that you can place the charged particle on the corner. And number fourth is that you can place the charged particle on the edge of a cube. Like this it is. For example, here I am making the cube like this. Okay, the charged particle is placed somewhere on the edge. Okay, so it's like this. Here the charged particle is placed. It is placed on the edge. Clear to you? So suppose the charged particle is placed here. Okay, so this is the charged particle. Okay, so in this very case, again you are supposed to calculate. First of all, you will have to calculate what's the net flux and flux per phase. Okay, so this is home assignment for you. I'm sure you can do it. First of all, calculate Q enclosed, that will be equal to Q divided by 4, because this charged particle will be equally shared by 4 different cubes. So the charge enclosed by this will be equal to Q by 4. Once you're done with that, you can calculate the flux what is received by this cube. That will be equal to how much that will be? That will be equal to Q divided by that will be in turn equal to this Q divided by 4 epsilon naught. Then if you are interested in calculating the flux through what? Through one side, so there will be two adjacent sides through which the flux will be not equal to 0. One is this adjacent side is ABCD. Through the ABCD, the flux will be equal to 0. And through this, suppose AB, this is D and E. So through this ABCD, the flux will be equal to 0. Through this ABDE, the flux will be again equal to 0. Then how many these phases are left? So there are 4 phases left. So that the flux per phase will be equal to 1 by 4 into Q divided by 4 epsilon naught. So that's going to be Q divided by 16 epsilon naught. And the flux through this will be equal to 0, and this will be also equal to 0. You will try it yourself. ठीक है ना बेटा? तो थोड़ा सा hint मैंने दिया. Okay. So we are done with this type of example. Okay, and you can expect a question on this even in the competitive exams. Right? Okay. Next, next is question number 1. Okay, let's do it later on. Question number 1 बाद में करते हैं. Okay. So let's switch to question number 2. Example number 2, I have already shown it to you. Okay, देख लेना बेटा. Okay, so I have already shown it to you. So it has been asked in the JAS 2017. So let's solve it out. You just concentrate here. Okay, so what I will do is that I will make a diagram here. The diagram is given in the question. Okay, so the diagram is like this. Let me make a diagram for you. Then you will first of all you will try it yourself, and in case you are not able to work it out, then I will show it to you. So this here it is given that this y-axis, this is z-axis, and this x-axis. Fine. Then here we have a cube. Okay, so cube is like this. So this is a cube here. So this is a cube like this. Okay, the side of the cube is given that's equal to L. Okay, its dimensions are L. It's a cube whose length is equal to L. Okay, and this also equal to L. So this equal to L. This here x equal to L, and this here x equal to L. X equal to 2L, and this here x equal to L. X equal to L. Fine. Okay. Then the electrostatic field is given to you. Let me write down the electrostatic field here. That's equal to K under root X. X raised power 1 by 2 is under root X. So here I will write down electrostatic field is given to you. That's equal to K X raised power 1 by 2 multiplied by X cap, or I cap 1 and the same thing. So in this direction, electrostatic field is direct. And number first is that it's variable electrostatic field, isn't it? It's a variable electrostatic. अब देख लो बेटा question क्या है? Question is like this. Calculate the total charge enclosed by the cube. So can you calculate flux first of all? So you can obviously calculate flux. Once you're done with the flux, then from there you can calculate Q enclosed as well. Like this. अच्छी तरह से ध्यान रखना. Flux is equal to Q enclosed by epsilon naught, isn't it? Q enclosed by epsilon naught. So this in turn implies that if you want to calculate Q enclosed safely, you can write down the equation like this: epsilon naught multiplied by flux phi. Fine. So first of all, you calculate the flux. So पहले आप flux निकालो. Okay. So you see that the electric field is in this direction. It is direct along the x-axis like this. In this direction, there's electric field. Okay. Now, how many faces this cube has? This is how many faces it has? 6 different faces, isn't it? Through the 4 lateral surfaces, the flux will be equal to 0. Then we are left with the 2 end gaps. Number 1 is this one, A, B, C, D. Number 1 is this A, B, C, D. Another is this E, F, G, H. E, F, G, H. Number 1 is A, B, C, D. Number 2 is E, F, G, H. The flux through the A, B, C, D and E, F, G, H will be non-zero. And obviously the flux is entering the A, B, C, D and it is leaving from the E, F, G, H. And the field at the A, B, C, D and E, F, G, H is not same. You can calculate that from here. Okay, so first of all, calculate flux entry, then calculate flux leaving, then calculate the net flux. And you know that the flux entering is taken as negative and the flux leaving is taken as positive. Once you're done with that, then take the summation of the two. Okay, then you can calculate Q enclosed. So you try it yourself. तो खुद कर लो बेटा. Hello.
Yes, sir.
I'll give you two. I will provide you 2 minutes. In 2 minutes, you must be able to solve it. पहले क्वेश्चन समझ में आया या फिर से एक्सप्लेन करना है? क्वेश्चन समझ में आया?
सर थोड़ा रिपीट कीजिए.
Okay, देख लो बेटा. There is cube. First of all, there is a coordinate system like this, x, y, and z. Okay. Then there is cube like this. Okay. So first of all, make a cube. Fine. You can have that. Okay. So this one face that's A, B, C, D. Another face is this E, F, G, H. I made a cube like this. Fine. Electrostatic field is in this direction. Electrostatic field is given that's equal to K into X. So this is a non-uniform electric field. That means at this point and at this point, the electrostatic field will not be same. You will have to calculate what the net flux first of all, and then from there you can calculate Q enclosed. Okay. So let me show it to you. So first of all, what I will do is this: I will calculate the flux through ABCD surface. Let me calculate the flux through the ABCD surface. And through ABCD surface, the flux will be entering because field lines are direct in this direction. So field lines will be penetrating in and then coming out of this EFGH surface. Okay. So it will be obviously negative. It will be here how much? Minus E multiplied by A. Minus E multiplied by A, isn't it? So it will be in turn equal to minus. What is the electrostatic field at this surface? At this surface, X is equal to L. So X के बदले L लिखेंगे. Okay, so it will be like this: minus electrostatic field is equal to K multiplied by X के बदले लिखेंगे L raised to power 1/2 multiplied by area. So area of this will be simply equal to, it's a square, so its area will be simply L square. It will be L square. So the flux entering is equal to minus K multiplied by L raised to the power this here 2 to 4. 4 plus 1 is 5/2. So this is the flux. That is the flux through the ABCD. It is negative because the flux is entering. Angle will be 180 degree between the electrostatic field and the area vector. Fine. Next is that let's calculate the flux through the EFGH surface. EFGH surface. That will be positive. It will be plus E multiplied by A. E multiplied by A. But for this surface, जो ये surface है ना बेटा, electrostatic field will be equal to plus K multiplied by X raised to power 1/2. X के बदले लिखेंगे बेटा 2L raised to the power 1/2. 2L raised to power 1/2. And the area is obviously again L square. So that means this term will be something like this: root 2 multiplied by K into L raised to the power 5/2. L raised to power 5/2. So this is the flux through the EFGH surface. EFGH surface. And through the 4 lateral surfaces, the flux will be equal to 0. The reason is that field is directed along the x-axis. Okay. Now you want to calculate net flux. Net flux will be simply summation of the two. So this is here root 2. K L raised to power 5/2 will be a constant. So as said, it will remain because K L raised to power 5 इसमें भी है, K L raised to power 5 और इसमें भी है. So it will be root 2 minus 1. This is the flux, isn't it? And then you want to calculate what? Q enclosed. So next is that you want to calculate Q enclosed. So safely you can calculate Q enclosed by using Gauss law. That flux is equal to Q enclosed by epsilon. Now we are in search of Q enclosed. This implies that this Q enclosed is equal to epsilon naught multiplied by 5. I have already shown it this type of example already. Non-uniform electric field पर हमने already एक example की है. Okay. उसमें हमने यहाँ से लिया था x-axis और यहाँ से y-axis, यहाँ z-axis. Okay. So it depends upon the question. Okay. The next is that you want to calculate what? So a flux कितना निकला? That's like this. So here I will write down this epsilon naught multiplied by KL raised to the power 5/2 multiplied by root 2 minus 1. So ये है इसका answer. This is the answer to the problem. I don't think it's a rocket science problem. Quite easy. It's obvious. Okay. तो इसमें कुछ rocket science उतना ज़्यादा नहीं है. Okay. It's actually a class 12 or you can say that it's a BSc type problem. Okay. Ask it in just. Okay. So next देख लो बेटा. Next ये example हमने already किया बेटा. Paper 2013. Asked in paper 2013. It is simply like this, that there is a cube. So let me make a cube like this. And the figure is given to you. The figure I am making here, it is given to you. Exactly like this and exactly copy pasted from David Griffith. Like this it is. तो यहाँ पर एक charge particle रखा गया है बेटा. That's at the corner. So the charge particle is placed at the corner. Somewhere here that's called a cube. Then this is the shaded portion. It's also given to you that this is the shaded portion. Fine. You are supposed to calculate what is the flux through this. So first of all, what you will calculate is this. Q enclosed इसमें कितना होता है बेटा? Q by 8. Because this charge particle will be sheared by how many cuboids? 8 different cuboids. So Q enclosed कितना होगा? Q by 8. ठीक, number 1. Number 2, then calculate the flux through the cube. That will be obviously equal to Q divided by 8 epsilon. but you are supposed to calculate the flux through this. So flux through this will be how much? Suppose that is pi dash, the flux through this phase. It will be equal to, there are 3 phases which will not receive the flux, and there are 3 phases which will receive the flux. So 1 divided by 3 times. So 3 is a 24, so it will be Q divided by 24 epsilon naught. Here is constant. Okay, you can have it. So next example, example number 4. Let's do example number 4. Example number 4 has been asked in GATE 2020. Okay, again the diagram is given to you. So let me first of all make a diagram, and then accordingly you can do it. Okay, today's lecture is based primarily on the previous examples. Okay, so it's like this. First of all, let me draw a diagram. The diagram is like this. This is a cylinder which is given to you, a cylindrical surface. Exactly the diagram is like this. A cylindrical surface is given to you. Fine. Then a charge particle is shown somewhere here. This is a charge particle. Fine. Now the charge particle is moving in this direction along a straight line with a constant velocity. It's moving with a constant velocity. And then coming out of this tube along this direction, it's coming out. Coming out of the cylinder, sorry. It's coming out of the cylinder along this path. Okay, along this path it's coming out. Fine. अब देख लो बेटा question क्या है. A charged tube moving with a uniform speed enters a cylindrical region in free space at t equal to 0 and exits. That means here time is equal to 0. So t is equal to 0 when it enters, and this t is equal to capital T when it leaves, when it exits from the cylinder. Okay, t equal to 0 and exits the region at t equal to capital T. See the figure. Plot total electric flux versus time graph. Okay, through the entire cylinder. You will have to plot. What you have to plot is this. Okay, you will have to plot the pi versus t curve. अच्छी तरह से ध्यान रखना बेटा. So you will have to plot this, the flux versus time curve. So here it is time, and here it is flux versus time curve. Fine, flux versus time curve. Okay, अच्छी तरह से ध्यान रखना. When the charged particle is just outside this cylinder, the flux will be equal to 0, just outside. And when it is just inside, the flux will be non-zero. कितना flux होगा? When the charged particle is suppose the charged particle is here, so obviously flux कितना होगा? Flux यहाँ पर कितना होगा? That will be equal to Q divided by epsilon naught. Isn't it? Simply charge enclosed is Q divided by epsilon naught. Moreover, the flux through the cylinder, it will not depend upon the position of the charged particle. Charged particle यहाँ होगा, फिर भी flux Q by epsilon naught होगा. If the charged particle is somewhere here, the flux will be same. If the charged particle is somewhere here, the flux will be exactly same. Q divided by epsilon naught. The reason is this: the flux to a closed surface does not depend upon the shape and size of Gaussian surface. It does not depend upon the position of the charged particle inside the Gaussian surface. Okay. But once it leaves here, the flux will again become equal to 0. So that at t equal to 0, just when it enters, the flux is equal to how much? Flux कितना बनेगा बेटा? Flux will be equal to Q divided by epsilon naught. Isn't it? And then it will stay constant. It will stay constant after time capital T. And abruptly at time capital T, when it leaves out, the flux will suddenly become equal to 0. So flux will again be equal to 0. So this is T equal to capital T. ठीक है ना बेटा? So after capital T, the flux will be equal to 0. And at t equal to 0, after t equal to 0, the flux will be non-zero. ठीक है ना बेटा? So this will be the graph. Simple question. And that too asked in GATE 2020. Okay? ठीक है ना बेटा? तो इसमें कोई rocket science है नहीं. So easily it is done. It's quite easily done. Okay? ठीक है ना बेटा? So first of all, let me again explain to you. Before t equal to 0, the charge particle was outside, the flux was equal to 0. And after t equal to 0, after t equal to 0, the flux becomes constant, which is Q divided by epsilon 0. Then the flux inside the cylinder is independent of position, whether the charge particle is here or here, or whatever be the trajectory of the charge particle, that's not going to matter. That's really not going to matter. The reason is that flux will not depend upon the charge particle. Okay, so the flux is constant and suddenly becomes equal to 0. This is like a step function. Okay, step function तो आपने पढ़ा होगा. Next is this. अब ध्यान रखो बेटा. So next is this question number 5. अच्छी तरह से ध्यान रखना बेटा. Consider a charge Q at origin of three-dimensional coordinate system. The flux of electric field through the curved surface cone that is height h. You will here is it. I'll be showing a couple of more examples here. Okay, and that too, this question has been asked in net December 2015. So अच्छी तरह से ध्यान रखना बेटा. Okay, so how I'm going to solve it out. So it is ridiculously easy, highly easy. So अच्छी तरह से ध्यान रखना. So concentrate here. Now it's like this. So first of all, let me make a diagram. The diagram is given to you again. So let me make a diagram like this. So here I'm going to make a diagram. It's like this. This is a cone which is given to you like this. Fine. The cone is like this. And then it is given to you that the charge particle is placed somewhere here. This is a charge particle which is placed here. Okay. So the charge particle is placed here. This charge particle is equal to Q, which is placed at the base of the cone. Right? So this is a charge particle which is equal to Q. Okay. It is placed at the base of the A simple question is like this. Now this is the coordinate system, so this is given this x equal to 0, okay, etc. So this is simple. Now we'll have to calculate what the flux through this को अच्छी तरह से ध्यान रखना बेटा, okay. We'll be using here a rule, and that's called symmetry rule, simple symmetry rule. Avoid any sort of integration and all that. What I will do is this. I will say that this charged particle Q, it is symmetrically shared by two cones. Number one is this, and number second is this. I can make a hypothetical cube here, okay. So like this is the question, this is the diagram that is asking the question. So here I will make this diagram. So यहाँ मैं पहले diagram बना के रखूँगा, okay. And this question, this diagram has been asked in the question, and you are supposed to calculate simply what the flux through the lateral surface here. For the flux through the lateral, obviously through this surface it will be equal to 0, because these field lines will be running. They'll be running like this, okay. So they'll be running what? They'll be running parallel. Okay, so these are the electric field lines. So I say electric field lines only. So that means through this cap, through the circular portion, the flux will be equal to 0. Then flux will be through non-zero. Through this, the flux will be equal to non-zero, because there are some field lines which are penetrating through this. So non-zero flux होगा, ठीक है ना बेटा? So what I will do is this. I'll make a projection here. अच्छी तरह से ध्यान रखना बेटा. I'll make a hypothetical cube here. Hypothetical cone. I'll make a hypothetical cone, something like this. ठीक है ना बेटा? So something like this. Now obviously, this charged particle is equally shared by this cube and this cube. And moreover, suppose that there is 1 million field lines which are passing through this cube. So the 1 million field lines will be passing through this cube as well. So the field lines are like this. इस तरह से field lines है बेटा. ठीक है ना बेटा? So these will be field lines. So that means the flux through this. So what I will write simply is this. What is the charge enclosed by this cone that's equal to Q by 2? Because it is shared by two cones. ठीक है ना बेटा? Q enclosed how much? Q by 2. You are supposed to calculate flux. So simple. Q enclosed divided by epsilon naught. So that will be equal to Q divided by 2 epsilon naught. No rocket science at all. Simple answer. ठीक है ना बेटा? Flux is equal to Q divided by 2 epsilon naught. That's it. So that too asked in the net test number 2015. Then there's a possibility. अच्छी तरह से ध्यान रखना बेटा. Then there's a possibility. The question can be like this as well. Okay. So I will show a couple of examples on this. The question can be like this as well. For example, here we have, it is given to us that this is hemisphere. क्या चीज़ है बेटा? This is hemisphere. Okay. So like this here. And the charged particle is calculated what the flux through the lateral surface we have this. Fine. The flux through this will be again equal to 0. यहाँ से अगर आपको flux निकालना है ना बेटा, that will be equal to 0. यहाँ से flux non-zero होगा. यहाँ से flux non-zero होगा. ठीक है ना बेटा? So first up, step number first, calculate Q enclosed. What is the Q enclosed? That is simply equal to Q divided by 2. Once you are done with this, calculate flux. That will be safely equal to Q divided by 2 epsilon naught. Answer is exactly same. Answer is exactly same. ठीक है ना बेटा? Another question can be asked like this. So all these examples, they are based on symmetry, like this example number 2, based on the same concept. That's something like this. Suppose that here we have, this is this, for example, a cube. अच्छी तरह से ध्यान रखना. This is a cube. Okay, like this it is. So this is a cube, and then there's a charged particle placed on the surface, on a face of a cube like this. This is a charged particle which is placed on the face of a cube like this. And you are supposed to calculate again flux. So again, in this very case, this Q enclosed will be simply equal to Q by 2. Flux will be equal to Q divided by 2 epsilon naught. That's it. Problem is done. ठीक है ना बेटा? So this is our example number 1, example number 2. So I'm sure, yeah, ऐसे भी example आ सकती है बेटा, like this as well. This is a cylinder here, and a charged particle is placed here, somewhere here. So this charged particle Q. Again, for this, the Q enclosed will be equal to Q by 2, and you want to calculate flux through the cylinder. That will be equal to Q divided by 2 epsilon naught. Moreover, the flux through this, again here the flux will be equal to 0. यहाँ से flux 0 होगा, इस phase से flux 0 होगा. ठीक है ना बेटा? So this question was asked in net December 2015. Then I have shown you more examples on this format. ठीक है ना बेटा? Okay. Next देख लो बेटा. Next question number 6 देख लो बेटा, कितना आसान question है. Okay. And that too asked in year 2002. So let me first of all make a diagram for this. Again, the diagram is given to you. So first of all, let me make a diagram for this. So concentrate here. ध्यान रखना बेटा. Okay. So the question is here. Wait a second. So the question is like this. Okay. So let me first of all make a diagram for the question number 6. Okay. So first of all, let me make a diagram, and then from there on you can do it yourself. Okay. So ध्यान रखो बेटा. So it's like this, something like this. These are first of all two surfaces. This here one surface, a hypothetical surface, and then here we have this another surface. Okay. It's given to you that this surface S. It is given to you that this is surface S, and this here contour implies it's a curve like, okay, contour C. And then here we have charged particle which is given here, that's called Q1, and here a charged particle that's equal to Q2. Now this Q1 and Q2, they lie inside the contour C, and this Q2 that lies outside the surface S, and Q1 lies inside the surface S. ठीक है ना बेटा? अब देख लो बेटा question. This is the diagram that is given to you. Okay. Now the question is like this. Okay. Question is like this. Consider a set of two stationary charges Q1 and Q2 as shown in figure. Fine. which of the following statements is correct? You will have to see which of the following statements is correct. ठीक है ना बेटा? Electric field at point P is independent of P point यहाँ है बेटा. This is the point P. This is point P somewhere here. अच्छी तरह से ध्यान रखना बेटा. First of all, point number first is that the electric field at the point P will be contributed by both the charges Q1 as well as Q2. It will be contributed by all the charges that are in the vicinity. Fine. Number one. Number second is that the flux through the surface S will be contributed only by Q1 and will not be contributed by Q2. That means the flux through the surface S will be independent of Q2. ठीक है ना बेटा? तो अब देख लो बेटा question. A part is that the electric field at point P is independent of Q2. It's wrong statement because it will depend on both Q1 as well as Q2. B statement is that the electric flux crossing the closer surface S is independent of Q2. देख लो बेटा. The flux through the surface S will be only contributed by Q1 and it will be independent of Q2. ठीक है ना बेटा? Because the flux is contributed by those charges which are inside the surface, and Q1 does lie inside the surface S and Q2 lies outside it. So that means the second statement is correct. So see this is correct. ठीक है ना बेटा? Okay. फिर अब ये देख लो, divergence of electric field is zero everywhere. It's not possible. The reason is that there are charged particles, there are non-zero charged particles, so divergence zero हो ही नहीं सकता. ठीक है ना बेटा? The line integral of the electric field E or the closed contour C depends on Q1 and Q2. This is also the wrong statement. ठीक है ना बेटा? So what is the right statement? The right statement is only this: the electric flux through the closer surface S is independent of Q2. Okay, so we are done with this example as well. ठीक है ना बेटा? तो इसका आंसर है बेटा statement number this B is correct. So here I will write down B is correct. B part is correct. ठीक है ना बेटा? Asked in GATE. Okay. Next example देख लो बेटा. Asked in just 2080. A nice example. Okay. So again it's conceptual question. अच्छी तरह से ध्यान रखना बेटा. Again it's a conceptual question. Okay. So concentrate here. Let's do this example. Maybe it will be the last example we'll be doing here. Okay. So इसके बाद example number 8. Example number 8 is there and example number 9 is there. Example number 10 is there. Okay. So I don't think I can keep any example here home assignment. तो क्या करूंगा मैं, ये होम असाइनमेंट रखूंगा आपके लिए. क्या बेटा? एग्जांपल नंबर 8 is asked in NET December 2019, so this will serve as a home assignment for you. And example number 7 I am going to show it. अच्छी तरह से ध्यान रखना. Example number 7 and 8 they are interconnected, 9 and 10 are interconnected. Okay, तो अच्छी तरह से यहाँ ध्यान रखना. So let me show it to you. So have a look. First of all, what is given is this: the charge density as a function of this is given. So let me write down the charge density is given to you. It's like this: rho of R is equal to this, a constant rho naught multiplied by what? Multiplied by this R square minus R square divided by R square. So it's something like this: R square minus R square divided by capital R square. Fine, this is given to you. Okay. Then what you are supposed to calculate is for small r less than capital R and zero otherwise. Okay. So what does it mean? It means that the charge density exists only up to capital R and outside it will be equal to 0. The electric flux over the surface of an ellipsoid with axes 3R, 4R and 5R centered at the origin is you are supposed to calculate what? Electrostatic flux. अच्छी तरह से ध्यान रखना बेटा. How to calculate electrostatic flux? So this is our question number 7. ठीक है ना बेटा? तो पहले देख लो बेटा, थोड़ा सा इस पर डिस्कशन कर लेंगे बेटा. ओके. So for example, suppose that if small r is equal to 0, देख लो बेटा, if small r is equal to 0, this rho is equal to small r is equal to 0, so rho is equal to rho naught. ठीक है ना बेटा? And small r is equal to capital R. When small r will be equal to capital R, this rho will be equal to 0. Rho will be equal to 0. That means the charge density is something like this. अच्छी तरह से ध्यान रखना बेटा. So the charge is placed. It's something like this. Here, let me make a coordinate system like this. ध्यान रखो बेटा. Let me make a coordinate system like this, and let's suppose this x-axis, this is y-axis, and this is z-axis. Okay. It's purely your choice. You can take along this direction x-axis, along this y-axis, along this z, or you can take along this direction as the z-axis, and along this as y, and along this x. It's purely your choice. Fine. Now the charge itself here is something like it is placed at the origin, so somewhere here it is, and its radius obviously equal to r. The reason is that this charge it exists only up to capital R. It exists only up to capital R, and rho naught is given. Next देखो बेटा, अच्छी तरह से क्वेश्चन देखना बेटा. Okay, and rho is given as a function of r that's given. You are supposed to calculate the flux over the surface of an ellipsoid with axes 3r, 4r and 5r. अच्छी तरह से ध्यान रखना बेटा. Let's locate these points 3r, 4r and 5r. From here to here this is r, so obviously 3r will be somewhere here. तो ये 3r होगा. 4r यहाँ कहीं पे होगा बेटा. ठीक है ना बेटा? And 5r will be somewhere here, isn't it? 5r. Okay. Then it's a surface like this, something like this. This is a surface. This is a surface. Something like this. Okay, so this is that Gaussian surface. You can say that this is an ellipsoid which is a Gaussian surface. Okay, an ellipsoid. So this is that Gaussian surface. Gaussian surface. And you are supposed to calculate what the flux through the Gaussian surface. Obviously. Obviously, the flux through the Gaussian surface will be independent of the shape of the Gaussian surface. It will not depend upon the shape of the Gaussian surface. ठीक है ना बेटा? Okay, so what we are interested in is this. We are supposed to calculate the flux. Okay, so simply let's what we will do is this. अच्छी तरह से ध्यान रखना बेटा. I will do like this, that the flux will be equal to Q enclosed by epsilon naught. Q enclosed by epsilon naught, isn't it? Then here it is 1 by epsilon naught. This Q enclosed can be written like this. It's equal to integration of rho dV or rho d tau or rho dV. ठीक है ना बेटा? By d tau is what? It's spherical volume element, and the spherical volume element will be in turn equal to this. It is equal to surface area of the sphere 4 pi r square multiplied by dr, like this. Is 4 pi r square dr. ठीक है ना बेटा? Then substitute it here. So flux phi will be equal to, this is 1 by epsilon naught. Then what you have to do is that you will have to substitute the value of rho here. Okay. So we are running out of time. I think that the rest part of this will be shown tomorrow. Okay, so let's keep it as such, and the remaining part I will be showing it to you tomorrow. Okay, so take care of yourselves.
Okay, sir. Thank you, sir.